Okay, so now may I introduce our second speaker, Toniya Sundaram from Klaytn Foundation, with the topic Building on EVM Chains. Please get on stage.
Hey, hello. Good morning, everyone. It's exciting to see the ETH community in Vietnam right now. I know there are few, but then everyone is very interested in knowing what's happening in the crypto space and see how the ETH Vietnam community is. And yeah, it's very nice to see you all in person. And myself, Toniya, I'm from the ecosystem team at Klaytn. So we build and integrate the tools around the Klaytn ecosystem. And today I'll be discussing about building on EVM chains. So as part of this, my agenda would be like what is an EVM and what is EVM compatibility and how EVM compatibility is critical today and how Klaytn achieved EVM compatibility. And we'll see Klaytn, how it looks like as an architecture and a protocol, and we'll see how to build on Klaytn and also any EVM chain. So, as you all know, technically EVM is just a CPU to process the smart contract code on Ethereum, right? So smart contract code is nothing but the set of instructions which the EVM can execute on Ethereum, right? So for example, you can code any set of instructions like check a person's balance, token balance, and if he has a balance, and you can let him vote, or any kind of instructions can be executed on the EVM by writing in Solidity, right? So this feature, because of this, the EVM is like the heart of the Ethereum, and it's also Turing complete. And this has made the blockchain, the ledger-based blockchain, to be the distributed state machine, meaning this EVM has access to the state of the blockchain, and it can change the state based on the smart contract instructions or the events from an external entity. So, and also it gives us the, it offers us the ability to create dApps on Ethereum. So yeah, so now we kind of know, high level what is an EVM. And we'll see what is EVM compatibility and why it is so important to have EVM compatibility in other chains. So, because EVM has been the de facto runtime of on-chain smart contracts. If you take any other EVM, it has not been so popular or been used in any other chains. So EVM compatibility meaning creating a EVM-like smart contract execution environment in other chains so that you can easily migrate the dApps and extend the functionalities of the dApps to the other chains without having to rewrite any piece of code. So, and this feature, of EVM compatibility has been proven easy way for interoperability between the blockchains, right? So, and Ethereum network is also growing larger and larger every passing day. So there's tons of use cases being built on Ethereum, and there are also so many development tools being integrated in the EVM. So as standalones L1s and L2s, we tend to support the EVM to attract more users and use the existing tools, and also build some more innovative use cases in the ecosystem, and also support back to the Ethereum ecosystem. So if you see most of the popular chains like Avalanche and Polygon and Binance Chain and Klaytn, we are EVM compatible. So at Klaytn, along with offering the features and the uses of Ethereum ecosystem, we also have some unique offerings like higher capacity and low transaction fees, and and better use cases. So now we all know why EVM compatibility is important, but there's also something called EVM, Ethereum equivalence. So what's the difference and why is it important? So the EVM compatibility is just a part alignment with the EVM specification, like we know, and EVM equivalence indicates the complete compliance with the EVM specification. So when we say EVM equivalence, it in fact requires to modify and reinvent the low-level code, so it supports the entire Ethereum ecosystem, right? So in Klaytn, we support Ethereum equivalence. So we go one step far. So we are more than EVM compatible, so Ethereum equivalence. So you can run any tools which you run on Ethereum on Klaytn as well. So you can create the transaction the same way, you can sign the transaction the same way, you can build and you can send, and even the receipt which you get is going to be the exact same way. So it's easy to interrupt or build, between any EVM chains. So yeah, and in this feature is being released as part of version 1.8.0, which was available from early this year. So how at Klaytn we went beyond Ethereum compatibility and we support EVM equivalence. We'll see how we have done that. So in the node architecture, we have like two interface. So one for the Ethereum and the other for the Klaytn. And we support two JSON RPC namespaces. So the Ethereum namespace, the ETH namespace is to support the Ethereum formatted transactions. So for example, if you're using a ETH.getBalance or ETH.sign, you can use the same in Klaytn ecosystem as well. And we have the Clay namespace. This is to support the Klaytn specific features, and you can execute the Klaytn specific transactions using the Clay namespace. So we tend to keep EVM equivalent and we target towards that, and especially it's very difficult to keep EVM equivalent because recently we had the merge, and post merge it's hard to keep being EVM equivalent, right? But still we are focusing on that and we are trying to be as much equivalent as possible. So we have EVM compatibility and we also have Ethereum equivalence, and we support all the tools which you can use on Ethereum in Klaytn as well. So enough of EVM compatibility and all these. So now you might be wondering, there is already so many EVM chains, right? And every chains are EVM compatible. So why do you want to consider Klaytn, right? So for that I have these features which we can offer. So the first is we have a high performing mainnet. We can process around 4,000 transactions per second, which is very competitive compared to the other protocols, and it's flexible and customizable, meaning we have our own dedicated service chain. For example, if you are a business, if you want to run your own service chain, you can use our service chains. So, and you can customize according to your needs. So you can have your independent validator set as well. And it's hassle free. It's because along with providing the service chain infrastructure, we also provide the wallet and the explorers and the SDKs as a package. So for you, it's you don't have to build any technical component. You just have to do some configurations and start using the service chain and run your business on it. And we have flexible fee delegation and deterministic price structure, which I'll discuss in detail later. And the frictionless implementation comes into play because we support Ethereum formatted transactions as well. So it's easy for the DApp developers to build on Ethereum and also move to Klaytn for a high performing mainnet or make use of Klaytn features. So here we can see how Klaytn looks like as an architecture or protocol. So Klaytn was a get-for code base before 4 years, and since then it has been highly modified and streamlined in the execution layer and the gossip layer and the consensus layer and the storage layer. So we have almost crossed 100 million blocks in the mainnet since then. And we have a service-centric hybrid architecture. We have a layer 1 mainnet and we have a L2 layer 2 sidechain solution as well, which is the service chain. So basically the service chain has the same consensus mechanism as the mainnet, but you can run your own dedicated service chain. And we achieve some interoperability between the service chain and the main chain in the protocol level and by writing some smart contracts. And Klaytn has 1 second block generation and instant finality, meaning the block is consented upon and block is generated every 1 second. And at Klaytn we are concerned mainly about the data consistency over availability, if you are aware of the CAP theorem. And Klaytn has 2 second round trip transaction latency, meaning from the moment you submit the transaction to the blockchain and it gets processed and it is propagated to the entire network and you receive it back as a finalized transaction receipt. So the entire time takes only 2 seconds, which is very competitive in the real world. So I'll show the metrics in the next slide. And this is very much helpful in use cases like bridging. And we have 4,000 transactions per second. So in Klaytn, in the mainnet, we were able to process a normal Clay send transaction, a send transaction, so around 4,000. But for the smart contract transactions, it might vary depending on the function, because it might add some overhead. But even for the heaviest transaction execution, we were able to process around 2,500 to 2,800 transactions per second. And Klaytn has the governance council. So this is the, we have a POA kind of network, which is the permission validator set. So this governance council is the validator set. So they produce the block and generate the blocks. So we have some reputable node operators like Binance and Netmarble. Sorry. And finally, we have this service chain, which I mentioned about, the layer 2 solution. I'm really sorry. I was talking in the booth for many people, so I think it is affecting right now. But yeah, this is the Klaytn architecture and how it looks like as a protocol. So this is a transaction latency measurement, which we measured in the mainnet. And here you can see the other protocols which have more than 3-second transaction latency. And Klaytn has the lowest transaction latency, which is very competitive. And here you can refer to this Medium article to see how we conducted this experiment and how we came to this, how we took this metrics. I would say stability is more important when we consider this transaction latency. Because, for example, right now you're running a transaction and it takes 1 second, and after 1 hour it takes 5 seconds, and tomorrow it takes 30 seconds. So it's not quite stable, right? So we also measured the stability over a period of time. So if you see on the top, the graph shows the stability of the transaction latency in the Klaytn network, and in the bottom you can see the stability of the other protocols which we measured. So there's a lot of outliers in the other protocols, but in Klaytn, it's kind of stable. So this stability in the transaction latency obviously gives better usability. So I would say Klaytn has a better usability, and it's very much useful in use cases like metaverse and gaming use cases.
Hi everyone, now I'll be at the spot. Everyone.
So you might be wondering how we achieve these results, right? How it is quite fast and how it has low transaction latency. So this is mainly because of the service-centric hybrid architecture. So we have been on POS from the beginning, and particularly IBFT, which is a well-proven system. And so we use POS mainly for block selection, block proposal, and we use BFT for consensus mechanism. And we have a three-node architecture. So we have a core node, we have a proxy node, and we have an endpoint node. The core node is where the consensus mechanism takes place, and it is responsible to produce the blocks. And we have a proxy node. So this is like the gatekeeper or the sentry node, which protects the core node from the wild internet, and also makes sure the core node can produce blocks in time. And we have this endpoint nodes. The endpoint nodes are the gossipers of the network. So they provide they expose the RPC endpoints, so you can submit the transaction and you can query the data from the blockchain through this endpoint node. And you can see the service chain as well. And we have some bridging solution between layer 1 and layer 2. So apart from providing a very stable and high performing blockchain infrastructure, we also have some unique features which we can offer. So we have an extended account model with the updatable key pair, meaning, for example, if you have an account in Ethereum, you have a private key attached to a public key which is tied to single on-chain account, right? So for example, if you lose your private key, there is no way to recover your funds. So in Klaytn we have this updatable key pairs, meaning we can map multiple key pairs to a single on-chain account. So you can, if any of the private keys compromised, you can remove the key and you can add new key pairs as well. And interestingly, we can do on-chain multisig through this. We have multiple key pairs in on-chain. And it also allows us to do role-based access control. Generally, we do this in using smart contracts to give a specific role or access. But here, you can have a specific key pair to do the smart contract execution, and you can have a specific key pair to update, the private keys or remove the private keys. So you can set the access in this multiple key pair support. And next we have a multi-format transaction model, meaning we have different transaction types for smart contract execution and deployment, and also anchoring in side chains. And this is very helpful for doing on-chain fee delegation. So in general, in other protocols, what happens is the fee delegation is done using a relayer network. So they write the logic in a smart contract and they do some crypto signing magic in the off-chain. And we have this relayer network to pay the fee for the network. Which is actually a little expensive to maintain this, the infrastructure itself. But in Klaytn, we don't need any such layer network. Everything is done on-chain. So we have on-chain fee delegation. So it brings us really interesting use cases like cashless transactions. So for example, if you are a DApp developer, or if you have a business, if you want to develop an app in blockchain, right? So if you don't want the users to pay the fee for the transactions, maybe for the first few days to make it more usable, you can use this fee delegation so that the users have just to sign the transaction so that the admin, who is the DApp developer, they can pay for the transaction. So everything is done on-chain. And we have a dynamic and deterministic gas model. Meaning based on the block, the congestion of the network and the transaction rate, the block fee might go up or down by 5%. But even though it's a little bit dynamic, it would not cross beyond 750. So the range is between 25 to 750 GUE. The stone is equivalent to GUE. And we do not allow the tipping feature. We only have the base gas fee. So it's very much helpful because in Ethereum network, if you want to skip the queue and execute a transaction, you have the ability to tip. But because of this, there is a volatility in the gas, right? Gas price. But here we wanted to keep as low and deterministic as possible. So we have this deterministic model. It does not go beyond 750, and we do not allow tipping ability. And so I think I kind of convinced you or showed you the features and the advantages which we offer and which we have as a infrastructure. Now I'm going to show how to build on Klaytn and EVM chains as well, because we have as an ecosystem we have many tools which you can use to build on Klaytn, and most of the tools are EVM compatible, so you can also use in other EVM chains. So as an ecosystem, we don't want to be opinionated on what tools to use or what services we want to provide. So we try to give as many services as possible, and we try to build EVM compatible tools so that we give back to the community and we support the Ethereum community. So in the wallets, we have a custodial wallet, a non-custodial wallet, and a hardware wallet, and we have a multi-sig wallet, and we also have support for MetaMask Snap. And we are building an open source wallet which will be released as a beta version this quarter. So the green boxes are the ones which has Klaytn support, and the green and blue has both Ethereum and Klaytn support, so you can use on other chains as well. And the orange ones will be releasing the beta version by end of Q4. So for the open source tools, we have a subgraph service. So it's like the indexing solution like the graph. So you can make use of the subgraph service to efficiently query the data from the blockchain. And we have a dev sandbox. So if any one of you are new to Klaytn, Klaytn network or Klaytn blockchain, if you are an Ethereum developer before, so you can make use of this dev sandbox to get started. We have the boilerplate codes to get started, deploy, and play around. So, and we also have contract library and open source decks. And we recently released a beta version of the governance portal. We have a Klaytn online kit, and this is also a very critical tool to play around on what unique features we offer. So in the Klaytn online toolkit, there are options you can try the field delegations, there are options you can try the different transaction types and the multi-format account structure. And in the SDKs, we support Web3 ethers, and we have Cable.js to build the transactions which I explained before, which is unique for Klaytn in order to do fee delegation or any of those type of transactions. And we support Web3 Unity for gaming, and we are building a developer package. It's like all-in-one package to spin up your own service chain or to build your own metaverse game. And we have some integration SDKs as well. And for the explorers, we have Klaytn Scope and Klaytn Finder, and we have Block Scout Explorer. This is an open source explorer. So this is very much important or will be very useful for the community, because if you're running your own service chain or any chain, you can make use of this open source explorer and spin it on your chain. And so Oracle's Chainlink is available in testnet, and we have VibNet. So we provide Oracle services as well, and these are the RPZ API providers, and we have bridges like Orbit, Synapse, Seller, Wormhole. So yeah, so we have a pretty huge ecosystem, and we are still trying to develop as many tools as possible and make it EVM compatible and give back to the Ethereum community, and also grow as a platform and to provide a stable infrastructure for you to start exploring and start building on Klaytn. And so as we grow along, we would be happy to get more open source contribution as well. So ours is 100% open source, so you can start contributing to the core development, or you can start contributing to our dev infra packages like libraries and wallets and decks. And we also have opportunity for the dev ambassadors. So if you are willing to support Klaytn and grow the dev communities around the world, please feel free to reach out to any of us who is wearing the Klaytn t-shirt. And we also have a booth, so if you're interested in becoming a dev ambassador, feel free to talk to us. And we also have hackathons time to time and bug bounties to reward the open source contributions. And last but not least, we have an audit grant program. So even in this bear market, we want to support the community. So we provide 50% subsidy for the apps or the applications built on Klaytn. So if you are building any application on Ethereum, if you want to migrate to a high-performing mainnet, so you can start building on Klaytn. And if you want these smart contracts to be audited, we give 50% subsidy and get audited by top auditors in the space. So that's it, and thank you so much for your time and attention. Do you have any questions?
Thank you, Toniya. And everybody, do you have any questions for our lovely speaker? If not, then you have